Our Plug and Drive Studio 3 is our new software for commissioning our motor controllers and plug and drive motors. So here you can see our plug and drive motors in blue and black, and here on the right you can see an exemplary controller for an external variant. Maybe first of all, why do we have now Plug and Drive Studio 3? Maybe some of you know we also have Plug and Drive Studio 1 and 2. Plug and Drive Studio 1 is the dedicated commissioning software for our stock firmware version, which is 1650. If you have newer firmware versions or would like to use newer firmware versions, then you need to use Plug and Drive Studio 2. The latest firmware version that we have is 22.13. But the reason behind now also having Plug and Drive Studio 3 is a really new concept behind the software. In Plug and Drive Studio 1 and 2, the focus was to give the user the most important objects and settings in the UI so that you can set up the motor controller. But of course, this is kind of limited because sometimes you want to have also more elaborate settings in the UI and so on. And this is why we developed Plug and Drive Studio 3, which has the advantage that you can set up the whole software basically yourself, which was not possible in Plug and Drive Studio 2 or 1. And if we now open the Plug and Drive Studio 3, so maybe for your information, we will go through a few screenshots and descriptions in this PowerPoint presentation first. And of course, after that, we will also jump into the software itself and have a look at it. But first of all, if we open the software, we will see this template selection screen. So here you are shown a few different templates that you can choose from. And from these templates, you basically build up your own project. So these are now the templates that we offer with the software. You can, of course, start with a blank project, but this is something I would not recommend because it can be quite hard to set this up. So this is why we also have a few more templates. For example, if you have an external controller like the C5E or the N5 controller, we have a template for the CSL3, a separate one, because this controller is kind of special. It's not as programmable as our other controllers. That's why we have a separate template here. And of course, for our plug and drive motors like a PD4, PD6, PD2, we have a separate template as well. After you have selected the template that fits to your controller, just select it by clicking it, and then you can enter a project name here on the bottom right. Just write the project name that you want to have, and then with create project, you are directed to the next window to start your project. In this guide, in this presentation, we will use the template for a plug and drive motor because here on my desk, I right now have connected a PD4C via USB. So that's why we will focus on this. But if you, for example, have an external controller, it's not really much different, the template. Here on the left, you can see templates that you might have already used before, so you can easily access them here quickly. You can, of course, also search for a template on your computer. For example, if you have a colleague that has sent you a certain template and you have saved it on your computer, you can search for it here. But as I said, now we are focusing on the template PD motor, and if we open that, it will look as follows. So the software structure looks like that. The Plug and Drive Studio 3 has 4 main areas within the user interface. The first one is the so-called header here on the top. It includes some general controls to handle your projects and the controller, as well as some controls to configure the software. So we will have a look at this in a second, what you can do with these buttons. But this is the header part of the software. Second one here on the left is the project tree. This one is used to structure your template your project. So you have the project here on the top, then you can add certain systems. So a system is basically just your controller or your plug-in drive motor in this case. And then you can also group your system into different module groups. And these module groups then contain the controls and the modules themselves. Third is the work desk. So anything that you choose here on the left will then be displayed here in the display wall. So this is the main area where we are going to work on. So here you can set objects, read objects, establish communication. So this is the main working area of the software. On the right, which is the fourth part of the Plugin RevStudio 3, is the display wall. Here we have some additional functionalities that might be interesting for you. It shows, for example, a monitoring tab where you can monitor certain objects, a certain status of the controller itself. We also have a so-called OD monitor, which contains really every object that is available on the controller. Then we have a help. So if you click on a help sign here on the left regarding a certain object, then you will directly see the help from the technical menu. We will also see that in a second. We have the console, the error list, and NanoJ. But we will see these additional functionalities in detail. Then we go on here on the left in part 2 with the project structure. So if we open the template, we will see this project tree, which is used to structure your project and the included devices. It mainly has 4 layers. The first one is the project layer here on the top. In this case, it's called My First Project. This is the overall container for everything that belongs to your project. Yeah, the main project layer. The main project layer then contains the different systems, we call it in this case. But in the end, a system is just a single device. So if we talk about my PD4C head here at my desk, then system 1 is just the plug-in drive motor PD4C. Then we can have a look at the next layer, which is 3. In this case, it's called device settings. It's simply a module group layer. It's used to sort different modules into a group. The different modules, you can see them in the area 4 here. These different modules can be grouped into this module group layer so that it becomes nicely usable and you have a nice overview over the settings. You can also minimize module groups that you don't need that often, for example. The last one, the module layer, then contains groups of controls and functions. In the plug-in drive template, we have added the modules that are most important in our opinion. Something like basic setup, user units, motor tuning, closed loop settings, inputs, outputs, and brake, and NanoJ app. Of course, we will also have a look at all of these modules in the software itself afterwards. So as I said in the beginning, this structure that you can see here is not fixed. You can adjust the template according to your needs, according to your wishes. If you, for example, want to add a second system to your project, let's say you have a CAN bus system and connect a second motor to your CAN bus, then you can simply right-click on My First Project and add a new system, and it will show up here. Then we can add a new module to that system, a new module group in this case, by just right-clicking on new system and add the module group. And then, of course, you can also add different modules to that group. You can either do that with a right click, or there's also a button on the right, which we cannot see here, but you can also click that. And with properties, you can then rename the new module according to your needs so that you know what you want to structure there. Each of these items can then also be X and imported, including all the underlying layers. So if you export a system, then you of course have all the underlying layers like the modules included. So you can export this module group as a file, save it on your computer, and if you have a different template, for example, or start a new template, you can import that layer in your template. So you can easily transfer all the modules and layers between your projects. So let's have a look at the module structure. As I said, here in the middle, the work desk, that's the main part where we are going to work in the software. So if we click on basic setup, for example, here on the left, we will see all the controls in the work desk. So that's basically the contents of your module. These different controls like motor type, pull per count, and so on, these different controls can be grouped into so-called control groups, for example, called basic, current settings, and same as in the project tree, you can also minimize these parts so that you have a nice overview of what you want to use and whatnot. To add a new controls group, you just have to right-click on the module where you want to add it. And if you want to add a control, just right-click on the module group where you want to add it. Quite easy. These different controls are so-called parameters. A parameter is basically used to read or write a value, or you can also do that bitwise or bytewise of an index. You can select from different display options when adding a parameter. So for example, you have these normal controls where you enter a value. Sorry, this one, for example, poll per count, you just enter a value and write it to the controller. But you can also define drop downs where you select from different options that you want to write to the object that is selected here. These parameters and control groups can also be renamed just like the modules here on the left by a right click and then selecting properties. You can rename them. In addition to the parameters, we also have so-called special controls. You can see an example here on the bottom. A special control is basically a predefined UI element to do certain tasks like an auto setup, as in this example, or communication settings. We also have a few more special controls like NanoJ control, like a jog console, motion test. We will see those also later. This is also a part which will probably grow because we can simply add certain special controls to the software if we think there's a need for it. But this is the main setup here of the work desk. As we have seen, a parameter is a control to read and write a value to an index. It always shows a name here, for example, motor type or poll per count, which is basically the name of the index. I would always name them according to the manual because then you can also look that up in the manual. But if you like, you can also give any name to this index as you like. Next to the name, it will also show the actual value, which is apparently on the device. If we go back one slide, one important thing is here, this option, show current values. If you want to see the current values of the device, just check this checkbox. Then you will see the actual values in this place. Then we have an input box where you can write a certain value that you want to write to the index to. And next to this input box, we have a checkbox, which is kind of important because only if this checkbox is marked, then you can upload the marked objects with the set parameters button. What you can always do is also without marking it, use this button. With this button, you can directly write the value that you have put into the input box to the controller. But these get parameters and set parameters button will only work if and also the store parameters button will only write the values that are marked. So the set parameters button will transfer all the marked values to the controller, The get parameters button will read all of the parameters that are marked from the controller and write it also here in these input boxes. The store parameter is basically for saving, permanently saving objects. So it transfers the values to the controller and then permanently saves all of the marked parameters. Then I already mentioned them. We also have special controls in addition to the normal parameters. Special controls are available to handle specific functionalities of the controller. Let's go through the different examples or different special controls that we have right now. Auto setup, which is basically for calibrating your motor. It will measure the encoder alignment and some important motor parameters, which is important mainly for external controllers. If you have an external controller and external motor with encoder, if you have a plug-and drive motor, it's not that important because it's already done at factory. Then we have a special control for firmware updates. It's not shown here on the left. Yeah, but it's, as it says, for up and downgrading the firmware on your connected device. The next one can also be seen here on the left, simple jog mode control, which allows you to move the motor at two different speeds, a fast one and a slow one. And yeah, important to say maybe that as long as you hit this button, the motor will run. If you don't hit the button anymore, the motor will stop. So very easy control for testing your motor. If you want to have a bit more sophisticated test runs, then you can use the motion test control. This one is used to perform either single or sequenced moves in profile position, profile velocity, or in torque mode. So you can choose the mode that you want to use here in this dropdown. Then you can define how often you want to have these loops. You can choose once, a certain amount of time, or endless. Here on the bottom, you define, for example, in position absolute, your target position, the velocity you want to run to the position, the ramps, and also how long or the pause in between the movements. If you then hit start, then the motor will run to 500 with a velocity of 50, make a pause of 1 second, and then go to the next position. With these buttons, you can start each of these sequences individually. You can add more positions, of course, in this case, or delete certain sequences. That's the motion test. Next special control is NanoJ. For those of you who do not know, NanoJ is our integrated programming environment for our controllers. So you can upload standalone program to the controller, and this is the control that is needed to program your code, adjust your code, and upload it to the device. Last but not least, we have a special control for communication settings. So as an example, can open, you can change the baud rate or the node ID in these special control. All right. The next one is the status board. So if you remember, that's the area 4 in our Plugin Studio 3 software on the very right. First one is the monitoring tab. Here you can generate groups and show different parameters of interest to get really permanent feedback about the actual value of these parameters. In this template, we have grouped a few different examples. So for example, error code, operating conditions, actual values of the position of the velocity, also the actual values of the digital inputs, of the outputs, and so on, of the analog input. So here you can group certain objects of interest yourself, which you always want to track. For example, you could also add the status word, for example, of the controller. So here you're quite free, of course, what you want to add here and what is interesting in your application. Then we have the OD monitor. I think I already mentioned that. It shows a list of all available objects on the controller. The Help tab, it shows information about the selected object in the work desk directly from the technical menu. So this is also something new compared to Plugin ResStudio 1 or 2. We did not have such a help functionality there. The console is something that most of you might be confident with from Plugin ResStudio 1 and 2 as well. So this can be used to read and write certain objects by addressing them directly. Then we have an error list. It shows conflicts within your project. I will show you afterwards what kind of errors that could be. And then lastly, NanoJ, which is the integrated development environment, as I said. It shows information about the compiling status of the code and errors in your code. And as I said, you can, of course, upload the program from there. All right. Then our last slide actually on the PowerPoint is to show you how you would establish communication with a device. As an example, here you can see the PD4C, as I mentioned. So if you want to establish communication, we have to click on the project in the project tree, this one. So in this case, my first project. Then we select the bus type in this dropdown. In our case now USB. Then we select the adapter that is used for USB. And probably it will only be one, usually for USB. With scan adapters, we would see different adapters actually, but now we only have this one. So we connect to the adapter and scan for devices. If we scan for the devices, we will get a list of all the available devices then here in this list. And you can see now here the PD4C, and in the system column, we determine which system we want to connect this device to. So in our case, we only have system 1, so we choose system 1. With this connect button, we finally establish the communication to our plug-in drive motor. And if it appears to be green, then you can be sure that the communication is established correctly. So now we are connected to the controller, and I think it makes sense that we now have a look into the software itself. Okay, so we have seen it in the beginning of our training. If we open the plugin ResStudio 3 for the first time, we will see this template selection screen. So in our case, we have now connected a plug-in drive motor to our PC. So we choose the template PD motor. We can adjust the project name as we like, but in this case, I will just leave it as it is. Then we hit create project. Okay, it was opened on my second screen, but now you should be able to see it. So this is now how the software looks like. The first step would now be to establish the communication to our plug-in drive motor. In the bus type, you have a few different options. Basically, all field bus interfaces that we offer so far, apart from Modbus TCP and Ethernet IP. In this case, you would just use Ethernet with REST. But in our case, we have a simple USB motor, so we choose USB. We scan the adapters, but actually we will see it's only one. So we connect to this adapter. We scan for devices, and now we see we have one device connected to the USB bus, and this is my PD4C on the desk. So we choose now system 1, which is the only system that we have. And with this button, which is currently white, if we click on it, it becomes green, and we are now connected to our motor. Then I would just, simply go through all the different modules and controls that we have. So if you click on the system, you will get some general information about the device that is connected. So we have device name, hardware revision, firmware version that is running on the controller, serial number, just some basic information about the connected device. Might not be too interesting in some cases. Then we go into the different modules. In the basic setup, we have the special control for the firmware update. As we have mentioned, you can either load a file from your PC. Maybe important information for you, because we often get the question, where can I find firmware files? It's actually for Plugin Studio 3 a separate download on our homepage. If you go to software and then to download and then software, and then on the Plugin Studio 3 page, you have a separate download for all of the firmware files. But quite nice new feature in Plugin Studio 3 is the cloud update. So if you hit cloud update, it will simply take the most recent file from the internet to upload your device. And we go on here in basic. You have the most basic settings for your motor. Important, I think, in most cases you will want to use it, is this show current values, because then you of course see what is currently selected or set up on the device. We have a basic setting for the pole pack count, which is right now set to 50, which is correct for our motor since we have a standard 1.8 degree motor, stepper motor. But if you, for example, have a 0.9 degree stepper, you would have 100 pole pass. So if we change it to 100, you would just enter this here, and you will see the check or the input box is now marked orange. So it means this value differs from the actual value. And with this button, you basically write the value to the device. And now we see it's not orange anymore. So these are equal now. But we, of course, have a 50 pole pack count motor. So we enter 50 to write that to the device. Yeah, we have some basic settings for open and closed loop and current reduction. Maybe it makes sense to look at the help now, because sometimes it might appear that you don't know what setting is this. For example, if you don't know what is selected with open and closed loop, just click on this help sign here. Then you will get the basic information from the technical manual about this specific object. So in this case, open and closed loop is set with the object 3202, and then you get the help information from the technical manual directly here. Then we go on. The current settings. So for this motor, currently there's a peak current set and a rated current set. If we, for example, want to change this, let's do this as well. So this motor has a nominal current as well as a peak current of 4.2 amps. So we add 4.2 here and 4.2 here as well. Sometimes you get the information about the unit here directly in the name, but it is also displayed here in the input box as well, so that you know which unit you have to write to the value. So these are the current settings. Then we have the special control here for the auto setup. As I have mentioned, we can quickly do that. Important for the auto setup is that there is no NanoJ program running on your controller, because it would interfere with the communication in this case. Second important thing is that the motor is load free and can turn in both directions without hitting some mechanical block or something. So if we click that, the motor gives a short beep tone and then turns a few revolutions left and right. Now we see the auto setup has been completed. it is now necessary to restart the controller. So we click yes to restart the controller and take over the settings from the auto setup or the results. Just takes a few seconds and then we get notified auto setup completed. The next one is the jog mode. We have also seen it in the presentation already. So we have two different velocities that we can also edit. So if we, for example, say, okay, 500 RPM is too fast for me. I only want to have 200, then we can enter that here. And as long as we hit the button, the motor will run at that speed. Of course, you can now not see anything from my desk, so it makes sense to maybe introduce our oscilloscope functionality at this point so that you can see something. If we go here to the top to view, we have here the Windows button and we can choose the oscilloscope to show up. It will now be displayed here on the bottom. Maybe as a hint, you can also separate certain windows here. So if we click on the oscilloscope, then it will be shown in a different window, in this case on my second screen. In this case, we do not want to separate it, so it appears here on one screen. You can also separate the monitoring tab here on the right, and you can separate the NanoJ tab. Regarding the oscilloscope, if you click here, New, then you get the settings that you can adjust for your oscilloscope. You can also minimize the settings to really have a look at the oscilloscope then. But first of all, we need to set up our oscilloscope so we can add basically any object from our object dictionary. So if we go to the filter, you can now either search for a certain name that is naming the object, or if you know the object directly, that you can also enter the object, of course. So I might be interested in the actual velocity now, so that we can all see something, which is the object 66C. So we choose this object from our object dictionary. We click select. You can now define a few more settings here. So a certain color that you want to use. Then you can define in which view you want to have the object displayed. So we can also choose a second view for a second object, for example. The scaling can be defined. Either you do an auto scaling or you can simply define certain borders for the y-axis for the value to be displayed. In this case, we just use auto scaling. Let's maybe add one more object. So before we have searched for the object, now we search for the name. For example, if we want to have a look at the current, now we get all objects that have current as a description. We are now actually interested in the motor current. So we use this one, actual current. That's the current that is currently applied to the motor. Select. And now it definitely makes sense to use a different color for this object, for example, red. Then you have a few more settings for the oscilloscope. For example, a start trigger. You can, for example, do an immediate start. You can also say, okay, I want the oscilloscope to start once the motion test is started. We can also test that in a second, but now we do immediate. You can define a stop trigger. Either you say just manually, I just want to manually stop the oscilloscope, or we define a duration. So let's say a duration of, I don't know, 10 seconds would be 10,000 milliseconds, and the sampling period, let's leave it at 50 milliseconds. So now we have done all the settings. We can minimize this window. we want to have access to the jog mode, of course, but now we have an immediate start. So now we see the actual current, which is quite low, of course, because the motor is not powered yet. And in yellow, we have the actual velocity. If we now run the motor, we can, of course, see the actual velocity rising to 200 RPM and the actual current rising to about 200 milliamps because I don't have any load, of course, connected here on my desk. So this is how you would use the oscilloscope. Regarding the start trigger, which I think is quite nice. So we need to stop it again, have a look at the settings. So we can define the motion test as our start trigger. And if we now start our motion test, so if we now click start on the oscilloscope, nothing is recorded because the motion test is our start trigger. So if we click start, also the oscilloscope starts with the motion test. So this is a quite nice feature, I think. If we stop it again, I can also show you something that I actually like quite a lot, because if we go back to, here in the interval configuration, you can define a so-called overlap. Right now, we did not have any overlap. If we, for example, set it to 3, maybe let's use a bit less of duration, 5 seconds maybe. What happens now if we start the oscilloscope, which is then started with the motion test? It will now record for 5 seconds, and the overlap now means that the next oscilloscope values are overwritten. Actually, maybe let's use a bit less of duration and shorter interval. Motion test is the start trigger. Okay, the motion test now just takes a bit too long, but what you would see actually with this overlap functionality is that the next oscilloscope values are then overwritten to these, and the old values are displayed grayed out. So that's what the overlap means. But for now, I think we will go on. So that was the oscilloscope. We can now choose it to not be shown again. So that was our basic setup module group. Then we have another module group for the user units. So here you can choose the SI unit for the velocity and for the position. So for the velocity, the default user unit in the latest firmware version is revolutions per minute. If you want to change that, for example, to meter per second, then you can do this with these drop downs. Just write this to here, then we have meter per second, and then maybe it makes sense to use, for example, meter, or if we use 10 to the power of -3, then we have millimeter. So this is how you can set up your SI units in this tab. Of course, if you have a linear system, for example, then you need to define a feed constant. For example, the thread lead of your lead screw. If you have a gear ratio, then you can define the gear ratio here. The advantage is that your user units are then always after the gear, not after the motor. And in this case, the feed is calculated from the feed constant. Okay, but let's go back to revolutions per minute, and actually For example, you can also choose increments without any exponent. One thing that I did not show so far, if we now want to write all of these settings at once, we have here this set parameters, which I mentioned in the PowerPoint. We click that, you will be asked, okay, do you want to continue? Yes. Then all of the marked settings are written to the device. If we now go back and select different ones and say, okay, here I have different settings, and I want to say, okay, I want to have actually the settings from the controller in my template, then I go to get parameters. Do you want to continue? Yes. And then actually should be written to, okay. Okay, maybe that was a bit of a bad example in this module, because there are still some bugs maybe in our templates or in the software. So maybe we go back to the basic setup where it actually should work. So if we, for example, use a different peak current here and then go to get parameters. So here, this is how it should work with the get parameters. I have noted down this problem, so yeah, there will be updates coming and new templates, so don't worry about this one. This is how it should work, but I think the basic functionality of the get and set is clear with that. In the PI tuning tab, we have some controls and parameters for the motor tuning. We have the position loop, the velocity loop, and the current loop. The current loop is separated into the IQ and ID, which is the torque building current and the flux building current. So here you can adjust the tuning parameters, but basically, especially for plug and drive motors, the presets that you have here should be fine. But if you see, okay, with my load, the motor is not behaving as I like, then you can adjust the tuning parameters with these values here. Then we have a few settings, let's say advanced settings for closed loop. You have some additional functionalities in closed loop like auto alignment, real torque mode, slow speed mode, or activating the position loop for velocity modes. Then, as we have seen before, the auto setup will run at some predefined standard settings, but we have included here two additional settings that are sometimes helpful. Let's imagine we have a linear actuator where you don't have as much space for the motor to move. Then it might make sense to use the short auto setup run, because then the motor will not move to some block, for example, which would be bad for the auto setup results. You can also limit the speed of the auto setup in per mil with this setting. Here on the bottom, you can see the measurement results from the auto setup. So important for sensorless mode is resistance, inductance, and magnetic flux. So if you, for example, see there's no flux measured by the auto setup, you might want to repeat it for the sensorless to work correctly. You also get the feedback about the encoder that was recognized. So right now we have encoder selected for position, velocity, and current. Here on the bottom, you can also change if you, for example, say I only want to use the encoder for current control or only for position and velocity, then you can change this here for the interface 2, which is the encoder for plug and drive motors. the interface 1 is always sensorless, but since we are using an encoder, it does not really make sense to use sensorless here. But if you, for example, don't have an encoder and want to use sensorless mode, you can adjust the settings here. For example, switch on speed, switch off speed, and so on. So these are the so-called, I would say, advanced closed loop settings. The next one is for the digital inputs and outputs, as well as for the break settings. So our inputs, our digital inputs have certain special functions, our inputs 1 to 4. So you can activate them with this control. You can also select some advanced settings, like if you want to have the function inverted of the input, if you want to have, for example, 24-volt signals instead of 5-volt signals, if you want to use differential signals or single-ended signals, that can all be set here in the template. The same accounts for the digital outputs. Yeah, and the break settings don't really apply in our case because we don't have a break on our plug-in drive motor right now. But here you could define the timings of the brakes, when it should open, when it should close. Also PWM settings for the brake and so on. Last but not least, we have the NanoJ app in our plug-in drive motor template. So this is actually something new in the plug-in drive Studio 3. Maybe some of you are familiar with the NanoJ programming environment in plug-in drive Studio 1 and 2. We can open the NanoJ here on the right. If we go to show code, then we now see the project for our NanoJ environment. Maybe some of you know the basic project file is the PMM code CPP, also the header file, and 2 additional files for the NanoJ app. So the standard programming environment, as you know it from plug-in drive Studio 1 and 2, is still there, of course. You can simply write your code, compile it, and upload it to the controller. Of course, start and stop the code on the controller. That is really the same as in the old software versions. The new thing now is if we click Show Settings. Maybe some of you have worked with Nano Pro in before, which was the software for our very old motor controller generation. There you had this set bits and so on, where you could program the controller quite easily. So we kind of wanted to have something like this in the plug-in drive Studio 3 as well. I will maybe just minimize all of these tabs first so that we have a better overview of what these are doing. So first thing, if we have a very easy application where we have a few different inputs that define a certain movement, we can simply define, okay, if no input is active, then we don't want to have any reaction from the controller. If input 1 is active, for example, we want to do a homing. So it's start homing 1. And homing 1 is now to be set up here on the bottom. We open homing 1. We can define, for example, the homing speed that we want to run at, the direction, the target, which is basically the homing method, then what the next profile should be after the homing, and if needed, a pause. So this is quite easy. Input 1 just starts homing 1. Then we want to say, for example, input 2 start position 1. Then input 2 would just move the motor to position 1. And position 1 is set up here, for example, with a target position, certain speeds, certain speed and ramps. So this is really, if you only have a few inputs and a few movements that you want to make, then this is really easy to set up. If this is set up, you just click build and upload and run, and then you're already done. So you don't have to do any programming in the environment here. This is then basically built by itself automatically. But if you're now not satisfied or not, if a few inputs are not enough, we can also do the so-called profile select. So here we can, in this example, choose from 8 different profiles or bit masks from 000 to 111. So we define one of the inputs as the start trigger, so start profile, and then we choose input 2, 3, and 4 should define now our profile. So XYZ is just the bit mask now, and for example, input 2 should define bit X, input 3 should define bit Y, and input 4 should define input bit Z. That means now we can set up our 8 different profiles as we like, with all the settings to be made here. And now we can trigger our inputs 2, 3, and 4 on our PLC, for example. And with input 1, I can then start these profiles. So that's for easy programming of the controller. Of course, this is kind of limited. If there are additional functionalities that you need in the code which cannot be set up with the NanoJ app, you can still stick to the classic programming of the NanoJ, which, as I said, still works as you are familiar with, maybe from Plug and Drive Studio 1 and 2. But I guess for very easy applications and for people who are not that familiar with programming, it's really convenient to set it up just with these drop downs and then upload it with some buttons. So that's the NanoJ app. So now we are actually through all of the modules. Then I would like to go through the additional functionalities that we have here in the status board on the right. We have seen it in the PowerPoint already, but here you can see it in live, basically. Maybe let's make this one a bit smaller. In the monitoring, we have different groups of objects that are maybe of interest. So for example, we have the voltage that is currently applied to the motor, temperature on the PCB on the microcontroller. We also have the position actual value, for example. If I now turn the shaft by hand, you can see that the position increases. What else do we have? Velocity actual value. You should also have seen it. Okay, in this case, not, because we are not using any mode of operation, but this would be displayed in case we are using the jog mode, for example. So look at the velocity actual. If we run, so actually now, as you can see, the unit is not corresponding to this one because we have set it up here. But as we have seen, it will change. So if we set up the SI units correctly, then this also works. Then we have an input mask for the digital inputs. If I, for example, click input 1, so I have connected a very easy I/O board to my PD4C in this case. And if I hit the different buttons of the I/O board, I can see the different bits of the digital input object to be set. We have some additional objects or some additional information if a limit switch is triggered, if the reference switch is triggered. We also have an analog input on our controller, which I also connected. So if I increase the analog input voltage, we can see the digital value also increasing. So this is basically the monitoring. of course, you can, sorry, I forgot these ones. So in the status, we can see the status word bit mask. So we have here the different bits simply of the status word. Right now, we are in switch on disabled. That's why this bit is currently set. And here we have some limit settings. So peak currents, max motor speed limits, and position limits, which sometimes are important if you're, yeah, for example, your motor stops at some point and you don't know why. You can have a look at these limits. Maybe one of these limits is then activated. Okay, so that's the monitoring. Actually, what we did not account for yet is here this basic information on the bottom, which can sometimes be helpful, especially if you want to know if there's a NanoJ program running on your motor or not. So right now, there's no NanoJ program running, so it's off, which is important. For example, if you want to run the auto setup, some basic information about the interface and also the current firmware, and if there's an error apparent. Next one is the OD monitor. So here you really have all of the objects that are available on the controller. Depending on the controller, it can really be a lot, as you can see. But quite helpful for us in support is actually if you click read, all of the, you can actually do that, all of the values from the objects are read and displayed here in the table. And if this is done, we can click this dump. Then all of these objects with its values are written into a text file, into a dump file. And most of the times, it really makes a lot of sense to send this dump file if you have a certain support inquiry. Just send us the dump file from Plugin Drive Studio 3 with your questions, because then we have really an overview of all the settings on the controller, and most of the time we can find out the problem already according to the settings. Not always, but most of the time it's very helpful. Yeah, I guess the help, we already had that. The console can be used to read and write single objects. For example, if we want to read the status word 6041, just enter the object without any addition and hit enter. Then you will get the status word as a decimal value, as a hexadecimal value, and the binary bit mask. You can also write objects from the console. So for example, 6040, which is the control word, just write an equal sign and then the value you want to write to, and then you get the confirmation that the value has been written to the object. So the console is quite helpful if you have worked for some time with our controllers and know some of the most important objects, because then you can directly access them from the console. So it's quite fast and convenient, I would say, compared to the OD monitor, for example. Then we have the error list, which shows you conflicts in your project. An example of such a conflict would be if we, for example, copy the peak current, just copy parameter, and then paste it. Now you can see we have the peak current here as well as here. And for example, we write 2000 here and 3000 here. And now want to do set parameters. Then we get the marked parameter conflict detected. Please check error list. And now we get the information that we should not write, of course, two different values to the same object. So in the error list, you will always get some these kind of conflicts in your project. So we remove it again because we don't want to have that. And now we can write 3000 actually. And we can also store. We did not do this before. Here it will also ask you if you really want to permanently save these parameters. Yes, we want to. And now you can see that the conflict error is also gone now. All right, that was the error list. We had the NanoJ. Then I will quickly look what else we have. With file, you can create a new template, a new project. With open, you simply open a template file that you have on your computer. Then save the currently used template or exit the software. Under device, we had these three. Then you can do restore defaults. With this button, you can restart the device and you can also run NanoJ program from here. Under view, we had some of these already. Under Windows, you can choose additional windows or also remove windows that you maybe don't want to see. Under separate, you can separate these tabs into a separate window. One more thing, you can change the theme from dark to light. If you're more familiar with a light theme, I like the dark one better, actually. Okay, so that would be the main settings for the software itself. Help is not really that interesting. You have a help window here for the software, and here you have some information about us, about copyrights and so on. Okay, I think we are through the main functionalities of the software. Maybe it makes sense to just show you how you would adjust such a template now. For example, if you don't only have one system, but a second one, then you go on your project, right click, or that's basically the same. If you click on these three on this sign, you can also add a new system with, if you go back to here. So right now I only have one motor connected to my PC. That's why I want to link my motor now to our new system. So we go to here and choose our new system for our motor to be connected. And we are here. Then with right click, properties, you can rename the system. So now we would have, for example, system 2. You can also give a version, a description, and so on. But for now, we just change the name. Then, for example, you can copy the module from here, copy module, paste module, and we have it here as well. But of course, we can also add a blank module. Then you can set it up as you like. And maybe as an example, new control group. We can also rename that my first control group, for example. One more thing that we did not have so far is the visibility and editability. So you have three different options here. Visibility, if you can see the control or not, can be changed from expert to intermediate or basic. So if we choose expert, for example, editability is if you can change the control, or if you can edit it. Let's also do it expert. Then you can choose here on the top with view, and here with this one. If you now have maybe somebody from the factory where you don't want to have this control to be visible or editable, then you can change from expert to basic, for example, and then this control group disappears for a basic user. Also, some other settings like the firmware update and so on are now not displayed anymore in the basic view. If we want to go back and see our module, we would need to change to expert again. So now we can see also the NanoJ programming now appears again. So that's the functionality of this three different settings. Then we can add something to our control group, for example, a special control. Like, I think we had all of these already. So memo text, for example, we did not have this so far. It's quite easy. It's simply a text box where you can add some kind of text for the user. Then we can add another special control, for example, I don't know, jog console. And maybe we add a certain parameter. Now we can choose again from any kind of parameter, let's say maybe the actual velocity. And if we click next, then we can select between the different kinds of control or the visual representation that we want to have for this control. We have a standard control with the simple input box, read only, so just the value will be displayed. We have bit control, so we can manipulate the different bits of the object value. We can choose from drop down or a drop down list box mask control. Yeah, you can have a look at these different ones yourself, I guess. Maybe one of these we can choose now is colored list box control, which is quite nice, I guess. So now we have velocity actual value, and here you can see unknown. So we go to properties, and here for the parameter, you have some different settings now for this parameter, either a description, but in this case, we just have the data entry name from the technical manual for this object, which I think makes sense. We can choose the OD format, like if we want to have a decimal value, hexadecimal, or anything else. In this case, decimal might make sense. Then we can edit the list of our color list. So what we can do here is define a min and max value. So if we want to say, for example, between 190 RPM and 210 RPM, everything is fine. And we can enter a certain text here. So for example, fine. We can give corresponding color, for example, green. So we now have, so we can of course also add another values where we say if the velocity actual value is between 20 and 180, then this is bad for my application, for example. And we can choose a different color here, for example, red. Then we close it again. And now we will see if we move the motor. Okay, now actually we need to adjust the user units again. So we go back to revolutions per minute. That's the default value. Okay, actually there still seems to be a bug regarding the user units. What I wanted to show you is here that if we now move the motor at a certain velocity that we defined in our control, then this one will change to the text and color that we defined in the list. So this is how you can set up your modules as you like. As I said, you can copy and paste different modules. You can also export and import modules that you saved on your computer. All right, so I guess we are actually through the software.